Hello everyone, welcome to a new section, and in this section we will learn how to use OpenAI SDK for building AI agents. For that we need an OpenAI API key in order to interact with the models that are provided by the OpenAI. So we will use the GPT-4o mini model, GPT-4o model from OpenAI, and for that we need an API key. Okay, so open your favorite browser and search for OpenAI API. And this is the first link, API platform and OpenAI. So click on it and you will be redirected to this page. And on the top right side corner, you can see the login button and here the API platform. So click on this API platform and then you will be redirected to this page. And here you have to create your API keys. So here you can see the API keys option over here. So click on it and then this button, create new secret key. So click on this create new secret key button and here you have to create your uh, secret key or API key. So add any name and then click the create secret key button. Once you create the or once you click the create secret key button, then the OpenAI will give you the OpenAI API key and you have to store it securely because you cannot watch these things later. Okay. And one more thing is that the OpenAI API key is not free right now. You have to pay for it. The minimum amount is $5 in order to use the models from OpenAI. Okay, all right. So these are the steps that are required in order to get the API keys from OpenAI. So once you have the OpenAI API key, the next step is to open the Visual Studio Code. And here what I will do, I will create one folder and I name the folder as OpenAI SDK. And inside the OpenAI SDK, I create an environment file called .env. And here I will paste the OpenAI API key. So the name will be OpenAI underscore API underscore key. And here you have to paste your OpenAI API key that you just copy from the OpenAI platform. Okay, and in order to work with the OpenAI SDK for building AI agents, we need to install a couple of packages. The first package is python.env and the second package is OpenAI-agents. This is a very important package in order to work with the OpenAI SDK. Okay, all right. So this is the setup process in order to work with the OpenAI SDK. And in the next video, we will start writing code and we will create our very first agent with OpenAI SDK. So that's all from this video and I will see you in the next video. Thank you everyone. So in this video, we will see how we can create our first agent with the OpenAI SDK. So inside the OpenAI SDK directory, let's create one file and we name the file as create underscore first underscore agent dot ipynb. And here what we'll do, we create the first agent. Okay, all right. So so mostly we will see that how we can use the agent from the OpenAI SDK and how we can interact or giving prompt to the LLM and how we can get the response. Okay, so these steps we will see in this video. So first we have to load the dot or load the environment variables. So import OS and from plain text, let's change it to Python. And let's select the virtual environment, which is the generative AI hyphen vim. So it's connecting to the kernel and then this will execute this cell. Okay. Also from dot env, import load underscore dot env and load underscore dot env. Okay, perfect. So we have successfully loaded the the environment variables that are available inside the .env file. Okay, all right. Now let's create our first agent. So create a code cell, and what we will do, we create a first agent. Okay, so this is our first agent. So to create a first agent, we have to import the classes. The first class is the agent class, and the second class is the runner class, which actually the runner class is actually used to run the agent. Okay, so from agents, import agent and runner. Okay, let's create a joke agent. So whenever I pass a prompt or a serious note, the agent will make fun of that serious note. Okay, so joke underscore agent equals to the agent. So I create the instance of the agent class, and here I have to pass a name of that agent class. So name is, let's say, joke agent. Okay, and then we have to pass one instructions. It's like a system prompt that we pass to the LLM. So instructions, and here we pass one instructions. So here we write that uh, you are a funny assistant. Okay, so you can see the auto suggestion. So you're a funny assistant that tells jokes. You can also answer question about jokes and humor. Okay, okay, so let's change it. So you're a funny assistant uh, whose main purpose is to turn serious topics into jokes. Okay, that's all. So this is an instruction. You can also update, modify the instruction. This is just for the uh, a basic instruction that I pass. And then finally, what model I want to use. So here I write model, and let's say that we want to use the GPT 4o mini model. This model we want to use. And that's all. This is the agent that we have created. So I have to add a comma over here. Okay, perfect. So this is the very first agent that we have created. We have not passed any tools. Okay, we have not passed anything that we will see in upcoming videos. If you hover over the agent, so you can see that we can pass in number of things. For example, you can pass tools, MCP servers, okay, handoffs, then input guardrails, output guardrails, hooks, so many different things, and we will see many of these things, like we will see that how we can pass tools, how we can pass handoffs, input guardrails. So we'll see that how we can pass those things to the agent. But this is the first video, so we keep this thing as simple as possible. Okay, all right. Then how we can run this agent. Now to run the agent, we can also use the joke agent object to run the agent, but we will use the runner um, class to do that. Okay, so for that we called runner. Okay, runner dot run, and here we pass the joke agent. Also you have to pass a prompt. So let's say the prompt is the boy did not pass the exam. So this is a very serious note, and the agent will make fun of it. Okay, that we will see. Okay, now if you hover over the run method, and here you can see that the run method actually returns a coroutine object. Now, in order to handle the coroutine, what you have to do, you have to add a weight over here. Okay, and let's store the value into a runner variable, and then simply we print the runner. So runner dot final underscore output, and that's all. Okay, this is our first model, first agent. Okay, all right. So we don't need to pass a prompt. Okay, so we forgot to pass a prompt. Oops. Okay, so let's execute this cell and let's see what we get. Okay, so this is a response from the LLM. So, well, he must have been studying for a different exam, like how to fail spectacularly 101, something like that. So, the LLM actually make fun of this serious note. Okay, so this is how we can create our first agent using the OpenAI SDK. So that's all from this video, and I will see you in the next video. Thank you. Hello everyone. In this video, we will see that how we can pass one agent output to a second agent. Okay. So in our last video, we have seen that how we can create an agent and run the agent. And in this video, we will see that if we have two agents and how we can pass the first agent output to the second agent. Okay. All right. So I create a markdown cell, and what we will see that pass the first agent output to the second agent. Okay, all right. So I create a code cell and let me add code. So this is the code. Okay. So from the agents, I import the agent and the runner. And runner is basically the execution engine for the agent. So whatever agent we create, we can execute that agent using the runner. So this is the first agent, agent one, and the agent one is a researcher agent. Okay. So the instruction is the research the topic and summarize. And this is the agent 2, and the agent 2 is a writer agent. Okay, and the instruction is write a blog post from the research in 50 words or less. So whatever the topic we pass, the first agent, agent 1, will do a detailed analysis. It do the research, and then it pass the research to the writer agent, and the writer agent write a blog post. Okay, so the result one is await runner.run, and here we pass the agent one, and this is our prompt. A prompt is AI agents in healthcare. So this is the topic, and the agent one will do a deep analysis, do the research, and whatever the result we have, we store it into the result one variable, and then we pass the result one to this writer agent. So you can see await runner.run agent two. So we call the agent two, and here we pass the result one output. So the result one, which is this one, dot final output, and then finally the result two, and simply we print the result two. Clear? And for both the model, for both the agent, we use the same model, which is GPT-4o mini. Okay, all right. Now let's execute this cell and let's see what we get. Okay, so this is the blog post of the research in 50 or less than 50 words. So AI agents in healthcare enhance diagnostics, predictive analysis, and so on. So this is the summary of the research. Clear? Okay, so this is how we can pass one agent output to the next agent, and we can improve these things by using handoffs. So in upcoming videos we will see that what is handoffs and how we can pass how we can interact with multiple agents using handoffs. So that's all from this video, and I will see you in the next video. Thank you. Hello everyone. In this video we will see that how we can use the tool calling features in OpenAI SDK. So for that, let's create one file inside the OpenAI SDK, and let's name the file as um, tool underscore calling and dot ipynb. Okay. Now, before working with the tool calling, let's first see that how we can use the structured output. So first we see that how we can get a structured output from a LLM. Okay, all right, so let's create a code cell and let's import the classes. So from agents, okay, so from plain text to Python. So from agents, import the runner and the agent. Okay, all right, so let's execute, select the virtual environment. So it's connecting to the kernel. Okay, all right. Now also we need to import the base model because we need a structured output from the LLM. So from Pydantic, import base model. Okay. And from .env, import load underscore .env. And finally, invoke the or call the load underscore .env method. So let's execute the cell. Okay, perfect. So first we have to create a class, and the class should inherit the base model class. So what we will do, we ask a question or a prompt to the LLM. Let's say that I have rice, broccoli, and chicken. What can I make for the dinner? So based on that prompt or based on that input, the LLM generate a response, but we want a special structured from the LLM. Okay, so maybe we want the name of the dish, the ingredients that are used in the dish, what are the instructions we need to follow. Okay, the cooking time is required for the dish. All this information we need from the LLM. So for that, we need a structured output. Okay, so create a code cell. So class, then recipe, and then it inherits their base model class. And let's say that we have a name which is string. Then also we need the ingredients. Okay, so this is a list of string, then the instructions. Okay, this is a string, and then the cooking time. Okay, cooking time in minutes. So this is our custom class, and the LLM should return a name, ingredient list of ingredients, instructions, and the cooking time minutes. And Pydantic validate the response from the LLM. Okay. All right. Now let's create the agent. Now to create the agent, let's create the instance of the agent class, and here we pass the name, and the name is, let's say, recipe agent. Okay. Then instructions, and what type of instruction we have to pass. Let's say that and agent that generates recipes based on user input. Also you can customize the instructions. Okay, this is just for the example purpose. And we have to select the model, what type of model we want. So we want the GPT 4o mini model. Okay, and here we have to pass the recipe. So the output underscore type is recipe. So the LLM knows that how the LLM should structured the response. Okay, so this is our recipe agent. So this is our recipe agent. Clear? Okay, now the user input is this. So you can see the auto suggestion. I have chicken, rice, and broccoli. What I can make for dinner. So press tab, and then await runner dot run. And here we pass the recipe agent and the user input. Okay, and let's store it into the response variable, and let's print it. So print response dot final output, and that's all. So let's execute this, and let's see that what we get. So I press the execute button. Let's see what we get. Okay, now you can see that we have a name. Okay, and this is the name. Then we have the ingredients, and this is a list of ingredients that are used to make the dish. So 2 cups cooked chicken, diced, 1 cup uncooked rice. Okay, so these are the ingredients, and then we have, okay, instructions. So this is the instructions. You can see that LLM generate these things in step by step. Okay, so first point, second point, and so on. And then finally we should have the cooking time. Okay, so okay, so you can see the cooking time minutes. So 65 minutes are required to make this dish. Okay, and also you can format the response. So this is how you can make sure the LLM should generate the response in a particular format that you want. Clear? Okay. All right. Now let's go to the tool calling part. So let's create a markdown cell, and let's call tool, tool calling. Okay. So what we'll do, we will create custom tools, and you know that how we can create custom tools. We create custom tools by creating methods or function in Python. Okay. All right. So first we need to import the function tool. So from agents, import runner, agent, and function tool. Okay. All right. So let's create two method. So what we will do, so we will create two tool. The first tool is the get weather tool, and the second tool is the get temperature tool. So let's say that we ask a prompt or a question to the LLM that what is the current temperature and the weather of a particular city. So when we ask this type of question, the LLM will use those two tools, the get weather tool and the get temperature tool, to fetch the information of a particular city. Okay, the weather details and the temperature details of the particular city. Okay, clear? All right. So let's create our first tool. So def get underscore weather, and here we pass the city, which is type of string, and the return type is going to be string. And also we have to pass the decorator so that the OpenAI SDK understand that this is a tool. So tab function tool. Okay. And what is the first step? The first step is that whenever we create a tool, we have to add a proper doc string. That doc string is very important or essential to help the LLM understand what exactly the tool is doing. So here we write get the current weather for a given city. And what we will do, let's say we print something. So we print that get weather tool call. Okay. So we understood that this tool is invoked. And then let's invoke return a simple string. Let's call it sunny. So in real production application, you basically call an API, a third-party API, in order to get the weather details of a particular city. But this is for a testing purpose, so we just simply return a sunny. Okay. All right. Now let's create one more tool. So function tool, and this tool is to get the temperature. So get underscore temperature, and this is auto suggestion. So you can see. Okay. So again, it takes the city, and this is the doc string. Get the temperature. Okay, so get the current temperature for a given city. Okay, so let me add that. Okay, and this is the print, and this is the return statement. Okay, so these are the two tools that we have. Now let's create the agent. So to create the agent, we write the weather. Uh, okay, so we create the instance of the agent, and here we pass the name, which is the weather agent, and here we pass the instructions. So I follow the auto suggestion. So press tab, an agent that provides weather information based on the user input. Then the model, which is GPT-4o mini, and finally here we pass the tools. So you can see the tools is a list, and in the list we pass the get weather and the get underscore temperature. Okay, all right. Now let's store that into weather agent, and how we can invoke that agent or how we can execute that agent. So to execute the agent, we call await runner dot run, and here we pass the weather underscore agent, and let's pass the prompt, and the prompt is what is the current weather and temperature of Kolkata. Okay, so this is the prompt, and let's store it into the response variable, and then simply return or print the response. So response dot final underscore output. And that's all. This is how we create an agent, and this is how we can pass tools to the agent. Now, when we execute this, the agent understand that, okay, this is so I have to invoke tools. And what are the tools I have to invoke? I have to invoke the get weather tool to get the weather of the city, which is Kolkata. Kolkata is the name of the city. And then I have to invoke the get temperature of the city Kolkata. So this is how an agent invoke or call the tools, and this is called tool calling. Okay, all right, now let's execute this cell and let's see what we get. Okay, so we get an error. Okay, name function tool is not defined. So for that, we have to re-execute this thing. Okay, now let's execute. Okay, let's see what we get. So you can see the get weather tool calling and get temperature tool calling. So two tools are invoked, and this is the final output. The current weather is in Kolkata is sunny with a temperature of 25 degrees Celsius. Now here you can see that the response is quite formatted, but in the two methods, the get underscore weather and the get underscore temperature, we just simply return sunny and 25 degrees Celsius. But in the final response, the current weather in Kolkata is sunny with a temperature of 25 degrees Celsius. So what happened behind the scene is that when we ask a prompt, the prompt is first passed to the LLM. The LLM understand is that I have two tools. Okay, I have two tools, and I have to first invoke the first tool, which is the get weather, to get the weather of Kolkata, because I cannot directly get the weather of Kolkata city. I have to use a tool to get the weather. So it first call the get weather tool, and the get weather tool returns sunny, and then the LLM call the get temperature tool, and the LLM and this method return 25 degrees Celsius. Now the LLM has the information, which is the weather of the Kolkata city is sunny and the temperature of the Kolkata city is 25 degrees Celsius. Now the LLM format that response. That is why we see this type of formatted response from the LLM. Clear? Okay, so this is how we use the tool calling feature using the OpenAI SDK. So that's all from this video, and I will see you in the next video. Thank you. Hello everyone. In this video, we will see what is handoffs. So I have created one file called handoffs.py. So let me open the file. So handoffs is a way for an agent to invoke another agent. Okay, so let's see that how we can implement that using handoffs. So first we import the load underscore dot env from dot env package. Then from agents package, import agent, runner, function tool, and handoffs and run context wrapper. So this we are familiar with, but we have not seen what is handoff and what is run context wrapper. And that we will see in this video. So what we will do, so if you come over here, you can see that we have a main agent, and the role of this main agent is that a student can ask a question, okay, for maybe for their homework. And if the question is related to math problem, then this agent, the main agent, call the math agent, okay, based on the question from the student. But if the question is not math, instead this is an English related question, then this main agent will call the English agent. Okay, so you can see that based on a condition, the main agent decides which agent to call. So in our LangChain playlist, we have seen that how we can implement the sequential chain, parallel chain, conditional chain. So those kind of an patterns we can implement using handoff. Okay, so main agent equals to agent, and we name the agent is main agent. And here we pass one instructions. Instructions is nothing but system prompt. So an agent that helps student with their homework. If okay, if the student has a math problem, then hand off to the math tutor agent. If the student has English problem, hand off to the English tutor agent. So these instructions we pass to the main agent. And in the handoffs, so this is a new parameter in the agent. So if you hover over the agent, you can see that we can pass name, tools, and hands-offs. Okay, so in the hands-offs, we can pass different hands-offs. So this is a list. Okay, so this is a list, and we can pass in number of agent over here. So I call the handoff method, and inside the handoff method, I pass the agent. So this is our first agent, which is math tutor agent. And how do we know that this math agent is called? We need some kind of an log statement or print statement. For that, we have one or more parameter over here, which is on underscore handoff, and which is on math handoff. So this is a custom method that I have created. So def on math handoff, and it accepts the context CTX, which is the type of run context wrapper. And then I simply print a message, which is handing off to math tutor agent. This is just for logging purpose. Okay, so if the main agent invoke the math tutor agent, we have to know that the math tutor agent is being invoked. For that, this is the log statement. So the on math handoff method we pass into the on underscore handoff. Clear? Okay. Now this is a second handoff. A second handoff is English tutor agent. And in the English tutor agent, again, this is a method which is on English handoff. Again, simply for the logging purpose. Okay. All right. So when we call this agent and when we pass a prompt, so here you can see this is a main method, and runner.run, we pass the main agent, and this is a prompt. Okay, this is the main question from the student. The question is, I need help with a complex math problem, and the math problem is what is the integral of x square. So this is the prompt. So when it passed to the the main agent decide that which agent I have to redirect. Either I have to redirect to math agent or I have to redirect to the English agent. So the LLM will understand the question. So this is a math related problem. So the LLM or the main agent invoke the math tutor agent. So the next flow will go to the math tutor agent. So this is again an agent and the name is math tutor, and this is an instruction. The instruction is an agent that helps student with math problem. But here is a catch. The catch is that if the math problem is complex, hand off to a complex math agent. Now, this agent, the math tutor agent, is only responsible to solve simple math problem. This agent is not capable of handling complex math problem. For that, we need a complex math agent. So can you see the flow? We first pass to the main agent. The main agent decide which agent to call. So it analyze the problem. So this is a math related problem. So it calls the math tutor agent. So the flow goes to the math tutor agent. But in the math tutor agent, in the instruction, we pass that if this is a complex math problem, then hand off to our second agent, which is complex math agent. That is why you can see that here we pass one handoffs over here, which is a complex math agent. Now in the complex math agent, this is the agent and the name of the agent is complex math agent. The instruction is an agent that can solve complex math problem. And here is a handoff description. Handoff description is very important. It's just like a doc string that we pass when we create a tool. Okay, so this is very important. And the handoff description is important, and it helps the LLM to understand what exactly the handoff is actually doing. So here you can see the handoff description is use this agent to solve complex math problem. You can ask the student for the problem they need with help and then provide a step-by-step solution. Just like that, we have the handoff description for the math tutor agent and for the English tutor agent as well. Okay, so this is a description of what this agent will do. So if you read it, you can see that for the English tutor agent, the handoff description is use this agent to help student with English problem. Okay, you can ask the student for the problem they need help with and then provide a step-by-step solution. But the complex math agent, how the complex math agent solve a complicated problem, for that we use a tool. So here you can see that we have attached a tool. So again, function tool and def solve complex math problem. So this is a doc string and here we write our own solution. So this is what handoff in a nutshell. Clear? Again, a quick recap. The recap is that we first create a main agent. First, we define the problem, what problem we want to solve. Then we create a step-by-step workflow. Okay, so the problem is that a student can ask a question, either it is a math question or an English question. So for that, the main agent can redirect that to either a math agent or an English agent. Okay, so this is the first flow. So from the math main agent, it either go to the math agent or English agent. The math agent cannot solve complicated math problem. So it hand off to a complex math agent. The complex math agent has a tool, and using that tool, the complex math agent can solve complicated problems. And this is how one agent can invoke another agent. Clear? And this is handoffs. All right. Okay. So let me execute that and let's see that how what the response we get. Now how we can execute that. So for that, if underscore underscore name equals to main, you have to import the async IO because this is an async method. So you cannot directly call main, because if you call main directly, it will do nothing. It will just return the coroutine. So for that, we have to run async io.run and we pass the main method. Okay, this is how we can execute our async method. Clear? Okay, so let's go to the OpenAI SDK and Python. Then the name of the file is 3.handoffs.py. Let's press enter and let's see what we get. So again, the prompt is, I need help with a complex math problem. What is the integral of x square? See, what the result we get? First, to find the integral of this, you use a power rule of integration. Okay. So before that, you can see the message handing off to the math tutor agent. So the main agent call the math tutor agent. And how do we know that? Because we have invoked this log. Okay, or we invoke this main method, and this method print the handing off to the math tutor agent. That is why in the log we can see the handing off to math tutor agent. That means this agent is now invoked, but this agent have not called to this complex math agent, because this agent can maybe solve this type of problem. If it finds a complicated problem, then maybe it call this complex math agent. Again, you can add that using the method over here, which is on underscore handoff, and this is how we can check that this complex math agent is called or not. All right, so I hope you understand the video, that what is handoffs, how we can pass one agent output to the next agent, how we can create a conditional a workflow kind of a thing. Okay, so this is all about handoffs. I hope you understand the video, and that's all from this video, and I will see you in the next video. Thank you. Hello everyone. In this video, we will see what is tracing. Now, tracing is very important. And when we working with any large complex workflows, the tracing helps us to visualize the execution flow of the LLM. So in our last video, we worked with the handoffs.py and we have built a complex workflows, right? So this is our main agent, and based on the user prompt, the main agent decides either to call the math tutor agent or the English tutor agent. And when the controls goes to the math tutor agent, and here we also have a handoff. Okay, so here we also have a handoff, and the prompt is, if the math question is complex, then the math tutor agent should hand off that task to the complex math agent. But technically, the math tutor agent don't invoke the complex math agent or hand off to the complex math agent. It solves the math problem by its own. So if we have tracing, then we can visualize those tracing paths. That is why tracing is very important. Now, when we use the OpenAI SDK, the tracing automatically happens. We don't need to do anything. Okay. So if we go to the platform.openai.com, and here, if you go to the logs, so if you click on the logs and if you go to the traces, okay. So if you go to the traces, and you can see that there are a lot of workflows. So in the flow, we have the main agent math tutor. So if we click on it, and you can see that this is our first trace. So if you click on it, and this is the main agent execution. So you can see the system instruction is that an agent that helps student with their homework. If the student has a math problem, hand off to the math tutor agent. So this system instruction is basically this instruction. Okay, the main agent instruction, this instruction. All right. Okay. Now in the input, we pass, I need help with a complex math problem. What is the integral of x square? All right. Okay. So this is the main agent. All right. Now you can see that it handoffs to the math tutor. So if we click on it, and this hand off to the math tutor, but the math tutor don't hand off to the complex math tutor. So the execution stop over here. So we can by watching these traces, we can understand that, okay, first it goes to the main agent hand off to the math tutor agent, but the math tutor agent does not hand off to the main complex math tutor. Now the response of the math tutor agent is this one. So if you click on it, Now this is the response from the math tutor agent. So this is the output. See, this is the output that we get, right? So this is how we can find the traces, okay, of a complex workflow. And this is very important when we build a large complex workflow and when you have to debug that why certain thing is not working. Traces helps us in those scenarios. Okay. Now, a better way to implement the tracing, although we don't need to write any code for tracing, OpenAI SDK does all the things behind the scene, but a good way to write tracing is this. So here you can see that we created our agent. So this example we have seen in our very first video. So this is our agent one and this is our agent two. So agent one is a researcher agent and the agent two is a writer agent. And here you can see that with trace, and here we pass a string. So research agent trace. Now the trace we have to import from the agents. So from agents, import agent, runner, and trace. So basically we give a name to the trace. All right. So that's all. This is how we can, structure the traces. So let me execute this Python file. So to execute that, Python 4.tracing.py. So I press enter and let's see what we get. Okay, so OpenAI key is not set. Okay, so for that, what you have to do? Okay, so let me copy the code from here. So from .env import load env, and let me discard this thing. We don't need it. Okay, let's save it. Now let's execute this. All right. So this is the response we get from the writer agent. And let's go to the platform OpenAI. Let's click on the logs and let's click the traces. And now you can see that instead of agent workflow, we have a research agent trace. And this name we have specified over here. Okay, research agent trace. All right. So if we click on it, and so this is a researcher agent. So let's go to the researcher agent, and this is the output of the researcher agent. You can read it, and then it goes to the writer agent. So you can see the writer agent, and this is the output of the writer agent. So it summarizes whatever the researcher agent generate. Okay, so this is how you can debug these things when we have a complex workflows. Tracing actually helps us to visualize that what LLM generate, why certain thing is not working, and so on. Okay, so this is super important when we work with real projects. So I hope you understand that what is tracing. So that's all from this video, and I will see you in the next video. Thank you. Hello everyone. In this video, we will see what is guardrails. So I have created one file called 6.guardrails.py, and in this file, we will go through the code that what is the guardrail and how we can implement the guardrail using the OpenAI SDK. Okay. All right. Now, what is guardrail? Now, guardrail is a mechanism where we protect to generate harmful content from the LLM, and so that we cannot pass or we should not pass the content to the user. Okay, so let's say the user asks something and the LLM generates some biased result. So we first verify the biased result and then only we pass the biased result to the user. If the result that is generated by the LLM is not matched to our organization policies, then we simply return some other messages or custom messages that we want for that particular prompt from the user. Okay, and this is same for the input side as well. So when the user asks some prompt or ask some questions, and first we validate the question or the prompt that the user ask. If some content is strictly prohibited, then we will not generate that result from the LLM. So this is how we can reduce the cost of generating content. So for those scenarios, we use the guardrails. So we use the guardrails for both the input and the output. Okay. So here is one example. So what we are doing over here, we are creating a finance helper agent. So in the finance helper agent, the user can ask a financial advice related question, and based on that question, the agent can generate personalized answers. Okay, so here you can see that the main agent, okay, the finance agent over here. So this is an agent and the name of the agent is finance advisor, and this is the instructions, and the instruction is provide general financial educations only, never give personalized or guaranteed advice. So we added that instruction to the system prompt, but still the LLM can hallucinate, and still the LLM can generate some biased or personalized or guaranteed advice that we don't want, because let's say that we build this AI agent for an organization, and that particular organization don't want personalized or this kind of an response from the LLM. So we have to implement the guardrail over here, so that whenever the LLM generate the response, we have to first validate the response that the LLM generate. If it matches all the criteria from the organization, then only we pass that to the user. Okay, all right. Then this is the output type, and the output type is finance answer. So this is a finance answer. So finance answer is a class, and the class inherit the base model. So from Pydantic import base model. Now this is how we can create structured output. So we are saying that, hey LLM, generate the response, and the response should have an answer, and the response should have a disclaimer. Okay, all right. Then we use the model, which is GPT-4o mini. So we pass the name, we pass the instruction, we pass the output type, and we pass the model. But the most important thing is the input guardrails and the output guardrails. So in the input guardrails, we in the input guardrails list, we pass finance underscore input underscore guardrail. Now this is a method we have created, and same for the output guardrails. Now what is the meaning of these two properties? So input guardrails means, so when we ask a prompt to the agent, okay, so when we ask, basically when we ask a question to the agent or the LLM, this input guardrail will execute first before calling to the LLM. So here you can see that await runner.run, and here we pass a finance agent, which is this one. Okay, and the prompt that we pass is this one: give me some insider trading hack tips. Now insider trading for some organization, insider trading is a crime, so we cannot ask this type of question to the LLM. So when we ask this type of question, first the input guardrail will activate and it validate that message. If it has some keywords, for example, insider trading or hack, then we strictly return some custom message that, hey user, you cannot ask this type of question. This is no our it is not in our policies. Okay, or this is against our policies. So this is how we can add the input guardrails. Now if you go to the finance underscore input underscore guardrail method, so this is the guardrail. So finance underscore input underscore guardrail. Now here is the decorator that we have to use, which is now this decorator that we have to add, which is input underscore guardrail, and we have to import that from agent. So you can see from agents import agent runner guardrail function output run context wrapper, and then output guardrails and input guardrails. Okay, all right. Now here you can see that this is our method name and this is the decorator. Okay, then we pass the context, and the type of the context is run context wrapper. Then this is the agent, which is a type of agent, and these two properties is important when we create an input guardrail and output guardrail. And then the input text we pass. So note the third argument is the raw user string. So the input text is basically this text. Okay, give me some insider trading hack tips. Okay, all right. Now see that what we execute over here. Now this is a custom code. Whatever code you want to write over here. So we execute a command. So print running input guardrails for finance agent, and this is a list of keywords we will check. So you can see that insider trading, hack the market, manipulate stock, avoid taxes illegally. So these are the keywords we manually check using the regex. Now here you can also use some LLMs to actually validate the prompt from the user, because this is a very simple prompt. So we use the regex and we basically check these keywords are present into the input prompt or not. So we'll iterate over the illegal request, which is this list. Okay, and then if ray dot search, we pass the p. Okay, so we pass each and every item from the list, and we are checking with the input text. So if insider trading is present into the input text, if is hack the market is present into the input text, is manipulate stock is present into the input text, this are we are checking. And if it something is present, then we return a guardrail function output. This is very important. This is how we instruct the LLM that this is okay. So basically we are actually returning the guardrail output. Okay, so the guardrail function output, and here the tripwire triggered. Now trip of wire underscore triggered means that this is a block request. The further request should not go to the LLM. The execution should stop over here. That is the meaning of the tripwire underscore required equals to true. If this is false, so here you can see that this is false, then the next execution will go to the LLM. But here, because these keywords are actually present into the input text, then we set the tripwire underscore trigger equals to true. And here we pass a custom message. The message is input blocked, request contains prohibited financial keywords. But if the input is clear, that means this text or the keywords is not present into the input text, then we simply return the guardrail function output, and the tripwire underscore triggered is false. That means the next execution will go to the LLM. And this is our input guardrail. Just like that, we have the input guardrail, we will have an output guardrail. So whatever the LLM generate, we also validate that the LLM generates something which has guaranteed return or not, risk-free return or not, double your money or not, insider tip or not. This keyword should not be present into the LLM response. So in the output guardrail, so again, this is the decorator we have to use, which is at the rate output underscore guardrail, and this is the name of the method. Again, we have to pass a context, agent, and the output. Now this output is the LLM output, and we know that the LLM generate the output, which is finance answer. So we have created this finance answer class, and in the output type over here you can see that the output type is finance answer. So we know that LLM generate the response, and the type of the response should be finance answer. That is why in the output guardrail we pass the output, which is the finance answer. But for the input guardrail, we pass the input text, which is string. Clear? Okay, this is very important to understand. All right. Now, for the output, we are checking that output dot answer dot lower. Now, what is answer? See, answer is this one. Okay, this one. All right. Now, so we are just like that. Okay, so just like that, we are checking that these keywords are present into the LLM response. If it is present, then simply we return the guardrail function output, and the tripwire underscore triggered is true, and the output info is compliance violation, prohibited financial terminology. Okay, if these keywords are not present, then we simply pass that to the LLM. And that's all. This is how we can create our input guardrail and output guardrail. All right. Okay. Now, what happened that when this output guardrail function output will be triggered and the tripwire underscore trigger is true. So this will raise one exception. So we have to carefully handle that exception. So for that, you can see that we wrap that into a try except block. So inside the try, we call the runner.run. We pass the agent, which is finance underscore agent. We pass this the prompt, and if the tripwire underscore triggered is true, that means the exception will be happened, and we are checking that if this is a tripwire exception. So if the tripwire, that means this word is present into the e, that means the error is present into the error. If it is so, then we print compliance block. The agent's response was blocked for financial safety. If this is something else error, then we simply return a technical error. Okay. All right, so let me execute that. Now my question is, give me some insider trading hack tips. Now it should be blocked by the input guardrails. Okay, so let me try. So Python 6.guardrails.py. So press enter. Let's see what we get. Okay, so running input guardrails for finance agent, and now you can see the compliance block over there, and the reason is because the strip wire underscore trigger is triggered. Okay, because we cannot ask this type of question, which is prohibited for our application. Because now you can see the compliance block, the agent response was blocked for financial safety. Clear? So this is the guardrails, very important. When you build production level applications, you have to implement guardrails. All right. So that's all. That is all about the OpenAI SDK. Although there are many different things that are present into the OpenAI SDK, but these 6 things are the fundamental and the foundation of the OpenAI SDK. If you understand these all 6 things, then you can build real AI agents with OpenAI SDK. So that's all from this video, and I will see you in the next video. Thank you.